Hello, I'm Ryan Mullenbeck, Market Development Agronomist with Cargill. Today I would like to talk to you about seeding rates and how to optimize your plant stand for the upcoming year. I'd like to discuss how adjusting your seeding rate and targeting a certain plant population can lead to more uniform crops and higher yield potential this year. I will explain thousand kernel weight and why you should know this number. I will go over what the newest research is saying about plant stand population and what levels to target. I will give some reasons why adjusting seeding rate is important. And finally, I'll wrap up with some seeding considerations and best practices. Thousand kernel weight, or TKW, is sometimes known as TSW, thousand seed weight in canola. This gives us a measurement of how heavy our seed is so that we can calculate our seeding rate. A higher TKW means fewer seeds in a bushel, and so we need to adjust our seeding rate in order to make sure that we have the proper plant stand. This is a very important number to know because it can vary between varieties and between seed lots. Not knowing your TKW could mean seeding too heavy or too light and limiting your yield potential. TKW gives us an accurate representation of how large our seed is, and having this number allows us to have the most accurate seeding rates possible. It's best to get this done when you test your seed for disease and germination, and they can easily provide that number for you. Or you can count out 250 seeds and weigh them, and take that weight in grams multiplied by 4 will give you your TKW. In order to set the stage for the highest yield potential of any crop, we need to target a plant population that will provide that for us. We need our thousand kernel weight, our germination, and our survivability to calculate this number. Each crop has an optimum plant density range that producers should target, and rates need to be adjusted according to conditions in the field, the date of seeding, weed pressure, seed place fertilizer, and other pressures that may affect plant stand or emergence. Higher populations can overcome insect pressure like flea beetles or make a crop more competitive in weedy fields. Plant population targets are based on research findings that identify the plant population required to optimize yield by crop. Seed survivability or mortality is an unknown factor on most farms. The only true way to know this number is to take plant stand counts in the fall and see which plants made it all the way through the year to produce yield. You need to factor in seeding date, soil temperature, moisture, and texture, as well as soil-borne diseases and insect pressures. The amount of seed place fertilizer and seeding depth are also factors that can affect seeding survivability. If you haven't done plant stand counts in the fall to see what your survivability is, you can use a few general rules of thumb. Cereals, you should take your germination and subtract 5 to 25%. And this number is probably closer to the 20% range to get your survivability. So a 90% germination crop probably has a survivability around 70%. Canola, that number is 60 to 65% depending upon the conditions. And lentils is very similar to cereals. You're looking at a survivability of 80%. Seeding rate is found by knowing a few pieces of information. When we calculate a seeding rate, we want to know how many seeds we need to obtain the targeted population. We find a number of seeds, and then that tells us how to calibrate our drill for a certain weight applied, not the other way around, where we take a weight or volume and then have that drive the number of seeds. This traditional method doesn't take into account seed size and survivability and often results in low and varied plant stand counts. So as you can see, to determine our seeding rate in pounds per acre, we need to first take our targeted plant population, our 1,000 kernel weight, our survivability in a decimal. So for example, a 70% survivability would be 0.7, and then we divide that by a factor of 10.4. So in this example, if we have a wheat crop with a TKW of 40 and a germination of 90, we can calculate seeding rate. The one wild card, of course, is in this calculation is the survivability or the mortality. And as we discussed previously, the only way to know this accurately for your farm is to take plant stand counts consistently in the fall to know how many seeds make it through to create yield. In this example, we're going to use 20% mortality or 70% survivability. We have a little bit higher plant population. It's likely drier conditions, and we know that the weaker seedlings will die off and leave a more robust stand. So in this example, seeding rate is going to equal 35 multiplied by 40 divided by 0.7 and divided by 10.4. And this will give us 192 pounds per acre. Now, obviously, this is much higher than a traditional 1.5 to 2.5 bushel per acre. But as you'll see, the increased seeding rate pays off in not only optimizing your yield, but also other benefits such as harvestability and evenness of maturity. With all crops, we tend to target the upper range of the recommended plant population to account for any in-season mortality and plant loss. If there is disease, frost, or insect damage, Having a higher plant population ensures that you don't experience a critically low plant population and suffer yield loss. Cereal seeding rate research is finding that higher plant stands get the best chance for maximum yield. Wheat and durum growers should target 35 plants per square foot, and barley growers should target 30 plants per square foot. Canola plant populations have been well researched, and new hybrids benefit from a plant stand of 7 plants per square foot. Lentil seeding rates should be targeted at 12 plants per square foot, with some initial research showing small reds do better at 22 plants per square foot, while peas and chickpeas should be at 9 and 4 plants per square foot, respectively. The benefits of targeting a higher cereal plant population based on TKW include fewer tillers and more stems. The main stem is responsible for 60 to 70% of the yield. More even emergence and crop uniformity will result from higher seeding rates. This will increase competition with weeds, improve herbicide performance, and reduce its use. It will also reduce flowering time, speed maturity, and improve harvestability. Barley seeded at higher rates results in lower protein, more kernel uniformity, and optimized yields and kernel plumpness. Canola performs best when we have 7 plants per square foot. Nitrogen use efficiency is improved, the crop is more competitive against weeds, and it makes harvest timing decisions easier. Canola can achieve 90% of its yield potential with as few as 4 to 5 plants per square foot, but a canola crop that misses this minimum threshold can see a dramatic drop in yield and profitability. The target of 7 plants per square foot allows for the loss of a couple plants to frost, insects, or other establishment threats. As we approach seeding, there are a few things you may want to consider to get your crop off to a strong start with even emergence and good germination. The first is to seed as early as possible and not let the calendar influence too many of your decisions. Let the moisture and other environmental conditions be the factors when you decide when to start seeding. You may also want to consider putting your most highly valued crop in first, as every day after May 1st reduces yield in all crops. Cereals lose about 1.3%. Canola was the most affected by this by losing 1.7% of yield per day, while flax was the least affected by delayed seeding. And also, getting malt barley in as early as possible will give you the best chance of keeping proteins low and obtaining a malt designation for your crop. Also remember that with canola, as with all crops, there is no correlation between seed size and yield. The keys are to get the crop in evenly, have the proper plant population based upon the size of the seed, and do other things such as having good fertility and a proper seed bed in order to maximize the potential of a good emergence and plant population. Seeding into dry soils can sometimes be inevitable. When this happens, the main concern is emergence. Dry soils will cause uneven crop, lower yields, and more weeds. Our aim should be even emergence and to get the crop out in a uniform manner. Chasing moisture and seeding deeper can lead to uneven emergence, as moisture will not be even across the entire field. Whenever we seed deeper, some of the seeds will go into moisture, but other seeds will be above that moisture level due to the variability of the field. And this will cause delays in emergence, an uneven crop, and other problems with harvestability and weed control. Shallow seeding and waiting for rain delays emergence, but often results in a more even stand and uniform emergence. Thank you for watching this presentation about seeding rates. I hope it gives you something to think about and gives you the ability to seed using 1,000 kernel weights and targeting a plant stand.